So let's talk about regular expressions, which give us the ability to write patterns for us to specify the rules of a lexeme with, right? So it's a notation for specifying textual patterns. And we tend to use these as we're building a language interpreter for specifying our lexemes, or the meaningful units of characters that are bundled together. But these have everyday utility in other formats as well. You used them earlier in the semester when using grep. So grep, the RE in grep stands for regular expression. And you were searching the files of a dictionary using simple regular expressions. They're also used in verifying inputs. So we can specify a pattern that says, hey, this is what would make up a valid email address. And then we can verify user inputs using a regular expression if it passes or matches the pattern that we specified. We'll learn that regular expressions describe a regular grammar, and we're not going to get into the formalities of this too deeply in Comp 211, but in Comp 455, you'll explore the really foundational theoretical basis for this. That was a landmark theoretical work done in the early 40s, 50s, and 60s in computer science. And so our goal in this course is to focus on pragmatic uses of regular expressions and provide some applications. And you'll then later go learn the theory that underpins them and gives us a really sound foundation to build upon. We'll also learn later in the semester, as we get into syntactical analysis, another kind of grammar, a context-free grammar that gives us more capabilities. And there's a way of you'll learn in Comp 455 of organizing these types of grammars into hierarchies of their expressiveness. So we're going to see what we learned today has some limitations. There are things that we can't express and match with using regular expression patterns, but we will be able to do that when we get to a more powerful grammar for context-free grammar. So I want to give you a brief, before we get into slides that are primarily written for reference purpose on how we think about regular expressions, let's try just sort of very casually describing a few of these operators that are inherent and important to the idea of regular expressions. So the first operator is the simplest one, and that is called concatenation. Right? Now you have seen this word in the context of strings, and concatenating two strings means joining them together. Well, we're going to learn concatenation in a slightly different way. So let's use I'm going to use an explicit operator here. So the operator, if I could spell the operator notation. For now, I'm going to use a dot to signify concatenation. And to give an example, we could say, for example, W concatenated with O concatenated with W. And so this is an individual character is on each side of this concatenation operator. And so notice we're saying W followed by O followed by W for the string wow. Right? And so this would be the specification of a regular expression. And if we wanted to try like some input that passes, so let's have another column here for passing input, or accepted input is what it's often called. What we'll see here is, for example, the string WOW would match this pattern, right? Because what this pattern is specifying is any string that has a W followed by an O followed by a W will match this particular regular expression. A rejected input example would be BAM, right? So BAM would be rejected here, okay? So concatenation makes sense. This one's the most straightforward. We're saying one character must follow another, or one part of a regular expression pattern must follow another, right? Oftentimes, I'm actually going to add another column here. This is the more formal way that you would specify a pattern that has concatenation. But because this is sort of the default, and so common that we want to specify sequences of letters that must follow one another, oftentimes this will be specified as an empty string, and we would just say WOW is the pattern, and it would match wow as well as BAM. Right, so this would, and it would reject BAM, right, or any other string that wasn't just WOW. All right, so that's hopefully a very straightforward and limited example of concatenation. Let's imagine another one, which is called alternation. And alternation we think of as OR. And I might just specify really quickly that we would often call concatenation and then, right? Or followed by. Right? So alternation is an OR operator, and the operator for OR is the single bar, and this is actually carried over in many other contexts and programming languages that have developed since regular expressions were first introduced. And so if we give an example of this, what I'm going to do is I'm actually going to go ahead and not try and specify this in isolation, but I'm going to specify this using concatenation as an operator. And I'll write out the concatenation specifically in this expression as well. So W concatenated with, and then I'm going to use some parentheses to group O or I concatenated with W, right? So we're seeing something that is an important feature of regular expressions, which is that they can be composed together. We just formed a complex regular expression by using both concatenation and alternation. So this alternation is O or I. And these parentheses are not matching characters. They're more like mathematical parentheses that allow us to group something that must be evaluated first. So here what we're saying is this is one unit, so we're going to have a W followed by either O or I followed by W. So a passing input would still be wow, but a passing input would also be WIW, woo. I don't know how you actually pronounce that. And a rejected input would be, say, WAW, right? So alternation allows us to start to specify OR, right? So we could say W or followed by O or I followed by a W, right? Similarly, we could use if I want to use the example where we have an empty string here. If we wanted to match either the word wow or the word BAM, right? So wow or BAM, we could imagine. Let me just make some dotted lines here. An input string that would match this would be wow. An input string that would match this would be BAM. But an input string that would not match would be, say, WAM, right? WAM or BOW, right? So there would be input strings that wouldn't match this pattern. So this is saying W followed by O followed by W, or, so this is a unit here, and we could have put parentheses around these two words, or B followed by A followed by M. And in these cases, I'm using the implicit concatenation operator. If I wanted to be more formal, we could have said W concatenated with O concatenated with W, B concatenated with A concatenated with M, and we could have put parentheses around these to be even more explicit, right? And so what we're saying here is wow connected by concatenation, or BAM concatenated, right? And so in this first example, it was W followed by O or I followed by W, and you can see that we can use this in other flexible ways. The last example operator I want to show off here real quick is the Kleene star, or the repetition, or the closure. I should use the word closure here, the closure operator. So the closure operator we would colloquially read as 0 or more times. Right? And this operator is the asterisk, okay? Now this one's kind of weird in isolation, so I'm not going to use it in isolation. I'm going to use it in an example pattern. So let's give the pattern W concatenated with O star concatenated with W, right? And what the closure operator says is match 0 or more of these characters repeated, right? And so an example passing input would be WW, right? Because 0 or more means it's optionally there. It doesn't, we don't have to have an O there. That would match and that would be okay. WOW would match because there's one O, or WOOOOW would also match because we can have an unlimited number of O's following one after the other. So what would be an example of something that's rejected? Well, WWO would be rejected. Just the string W wouldn't be enough because we have to have two W's to match this input. And you could imagine other things that are very obviously not matches would also be rejected, like BAM, right? This can also be used, this operator can also be used around groups of characters, right? So we could say W concatenated with O concatenated with W, and then 0 or more of that pattern repeated, right? And so I should use a different color for this, just real quick. I'll try this darker color. Let me just rewrite that. And I'm going to use the implicit concatenation operator. So notice this is concatenation of wow followed by a star. That would actually match the empty string because it's 0 or more of these. So the empty string would match against that. But the more interesting one would be this would match wow, wow, and then any number of wows following after that. It would also match the single wow. And what would be rejected? Well, if we had only a partial match, you could imagine that gets rejected here. Right? So this is a very informal, example-driven, trying to preview where it is we're going with regular expressions. It's a way of specifying patterns, which we saw in these columns, or in this column, that will allow us to match input text against that and decide whether some input text will be accepted or it matches the pattern, or if it would be rejected by that pattern. And we can use this to specify rules for our lexemes and for other pattern matching purposes in text. Next, we're going to look at these a little bit more formally.